Okay, so here we are with our Unit 2 test review. These are the test topics which you've already been given. And topics of the video, we'll narrow it down to just these 6, some of which are related. First, we're going to start with quadratic functions, investigating, so completing the square, and then some graphing shortcuts with that, solving and investigating quadratic functions. The quadratic equation we're going to use here is x squared minus 4x minus 5. And the goal here will be to rewrite that in graphing form. And the method we use for that is something called completing the square. Okay, so remember the steps of completing the square. First of all, there is a formula for that. If you didn't know this yet, you can have this in your toolkit. What we're going to have here is a, and then we're going to have x minus b over 2 squared. Okay, and then we're going to add, now what we add here is usually c minus a times b over 2 squared. Okay, so if you really want a formula for that, this formula here would work every time, where you just substitute the numbers that you have in your particular equation. Okay, now here our a value is 1, so that makes that a 1, that makes that a 1, so it's just going to be c minus b over 2 squared. Let me rewrite that there, because that should be in parentheses. Give myself a little more room. Sorry, so this will be y equals a, and then x minus b over 2 squared plus, and then we have c minus, b over 2 in parentheses squared. Okay, and again, if you have an a value, that a value would go right here. Let's see here. But like I told you before on the test, we're probably just going to have one that has an a value of 1 like this. So in short, though, because some of you are getting pretty good at this, the process is to divide this number by 2. So negative 4 divided by 2 is negative 2. And then you square the negative 2. Okay, so 2 squared is 4. But I don't want 4. I want negative 5. So I just do negative 5 minus 4, and I get negative 9, which becomes my k value. So the graphing form there would be y equals x minus 2 squared minus 9. Remember all the things that tells us. Vertex. Apply graphing transformations to our answer. Okay, so if we were going to go ahead and graph this, then what we would want to do here is, first of all, let me give myself a grid. It's going to help a little bit. All right, so first, coordinate plane usually helps. And that's not good enough. Let's make this a little darker. Okay, so coordinate plane here. It's going to be down 9. It's going to open up. So I'm going to make this a little unbalanced. Okay, so apply graphing transformations. First of all, this is your h value and this is your k value. So the h value here is to the right 2, and the k value is down 9. So my vertex is going to be 2, negative 9. So I go right 2, down 9, and that's going to be my vertex. Now, graphing shortcuts for parabola always work the same, and here our a value is 1, which makes this nice. I'm going to go over 1, up 1, over 2, up 4, over 3, up 9. So if I plot those points, over 1, up 1, over 1, up 1, 2, and 4, always from the vertex. Okay, always from the vertex. Some people get confused by that. They'll go from the previous point. Parabola graphing shortcuts there always work from the vertex. And I go ahead and sketch the best parabola I can with the data points that I've been given. Solve the quadratic equation. So here we're looking for the x-intercepts. Anytime you see solve, we're looking for the roots of the quadratic. Okay, now I realize the previous problem we have the graph. We can figure out what the roots are. Okay, but I need you to be able to do that by hand as well. Okay. So best way to find the roots of a quadratic is to factor it. Okay, so two numbers that multiply together to give us negative 5. Okay. But when we add them, we get negative 4. So those two numbers will be negative 5 and positive 1. So minus 5 plus 1. Zero product property says we let each of those equal 0. And x plus 1 equals 0. So x will be 5, and x will be negative 1. Those happen to be our x-intercepts. So 5, 0, and negative 1, 0. Best answer is there. Okay, so remember all the forms of our parabolas that tell us all these different things will help us then with the investigation. Okay, so we've already graphed the parabola. I'm not going to regraph it. You can view back previous step. So graphing is done. Okay, remember that standard form, the best part about standard form, this is standard form, okay, is that it tells us the y-intercept. So in our investigation, the y-intercept is going to be 0, negative 5. The best part about factored form, which was the previous problem we just did, is that it tells us the x-intercepts, which we found in the previous problem to be 5, 0, and negative 1, 0. Okay, and then the best part about graphing form is that it tells us the vertex, or the locator point. In this case, for the parabola, the vertex is the locator point. It was 2, negative 9. There is no HA, there is no VA. Not applicable to parabolas. Okay, the domain, every time for a parabola, the domain will always be all real numbers, or you could write that as an inequality if that's what you prefer. The range of this parabola is always going to be the vertex, okay, to infinity, okay, or it could be negative infinity to the vertex. So for this parabola, it's going to be negative 9 equal to y to infinity, or you could say all real numbers greater than or equal to negative 9. All right, it is a function. And then to determine whether this function is even, odd, or neither, we plug in 1 and negative 1. Okay, so 1 squared minus 4 times 1 minus 5 equals, let's see here, 1 minus 4 is negative 3 minus 5 is negative 8. Negative 1 squared minus 4 times negative 1 minus 5. So negative 1 squared is 1 plus 4 is 5 minus 5 is 0. So this is neither. Okay. And from the looks of it, I think that's just about it. You could always give a table. Easy enough for that table. Just, I mean, put your x-intercepts in there. 5, 0. Okay, and negative 1, 0. Put your y-intercept in there. 0, negative 5, and your vertex 2, negative 9. That's good enough. Sequences, arithmetic and geometric. This is something that some of you have had a lot of experience with, some of you that have had very little experience with, but regardless, it's required information. So the first piece that we need to remember here is that arithmetic means add or subtract. Okay, geometric means multiply, whether it's by a whole number or a fraction, would be multiply or divide. So find the next three terms if it's arithmetic. Well, if this sequence were arithmetic, we have to add 6. So if I continue to add 6 each time, I will end up getting, for my next three terms, I will get 15, 21, 27, okay, for my next three. Find the equation if it is arithmetic. Arithmetic equations are always the same. It's always y equals mx plus b. Okay, you need to be familiar with that. M is slope, b is starting value or figure 0 or y-intercept. Keep in mind that this first number is not the y-intercept. It is the first term. You have to go backwards one time to get the 0 term. So negative 3 would be our 0 term here. So the equation for an arithmetic sequence represented by 3, 9, 15, 21, 27 would be 6x minus 3. I'm going to switch colors to represent my switch to geometric. If this were geometric, I'd be multiplying by 3. Okay, so if I'm multiplying by 3, my next three terms are going to be 27, 81, and 243. Okay, geometric sequences work the same as exponential functions. A times b to the x. A is your figure 0, and b is your multiplier. Okay, again, this 3 is not term 0. It is the first term. You have to go backwards 1 to get the 0 term, so you divide by 3 and get 1. Therefore, I would end up with y equaling 1 times 3 to the x power for my equation of that geometric sequence. So main idea here, people, is that you should know linear equations, mx plus b, and we should be getting more and more familiar with exponential equations, which is geometric ab to the x power. And those two things are vital to doing arithmetic geometric sequences. Just keep in mind that the term number, if I ask you to see, usually you'll see this as t of n equals 6n minus 3, or t of n equals 1 times 3 to the n. Keep one thing in mind. N must be a positive integer. It means it's got to be a whole number, it's got to be positive, the n value. There's no such thing as a half term in a sequence. Think about a ball bouncing. The ball can never bounce a half a time. The ball either bounces, okay, or it doesn't. All right? There's no half a bounce. When it strikes the ground, it bounces. Systems of linear equations. Again, this should be a big review item. You got to know it. We're going to be getting into more advanced systems of equations down the road. This one here is set up perfectly for elimination. We can just multiply this equation by 2, and that'll give us opposites here. Okay, so I'll end up with negative 2x plus 6y equals negative 22. We got to know this. This has got to be a gimme every time. All right, so if I'm considering that equation with this one, I would add them together. And the whole reason I multiplied by 2 to begin with is so that that cancels out. Last test, people just started adding these together. They add these two equations together, and they get x plus 10y equals negative 15. It does us no good. Nothing canceled out, so that's not good. We need something to cancel out. That's why we distributed the 2 first. So we have opposites here that make us 0. So 7 plus 6 is 13y equals negative 26. Therefore, y is negative 2. Don't stop there. Once you solve for y, solve for x. You can plug that y into either equation. So 2x plus negative 14 equals negative 4. So 2x equals 10. So x is 5. You could always double check that in the other equation. Negative 5 plus negative 6 is negative 11. Remember to write your answer as a coordinate, because that point is where these two lines would intersect on the coordinate plane if they were graphed. And again, we need to know this because in the near future we're going to be solving systems of 3 equations or more. Exponential growth or decay word problem. So here we're looking at that exponential function that we began with, y equals a b to the x. You got to have that in your toolkit, remembering that a is the initial value, b is the multiplier. Now the multiplier can be specific. Again, this one here deals with a percentage. Okay, therefore you need to have some information about percent increase and decrease. Percent increase is always 1 plus your percent divided by 100. Percent decrease is always 1 minus your percent divided by 100. That's the easiest problem in the book, people. Too many people got this wrong on the first test. Okay? A deer loses 4.5% of its body temperature per hour once dead. Sam shoot a deer? Okay, Sam shot a deer at 7:30 a.m. on the first day of deer season. Sketch a graph of the deer's body temperature if the outside temperature is 55 degrees. This is important because in an exponential function, the temperature is never going to go below what the outside temperature will be. So if I were to sketch a graph of that, my graph, okay, would need to have a horizontal asymptote at 55 degrees. Okay, and the y-intercept is 98.6, and it follows an exponential function. It never goes below 55 degrees though, because that's the outside temperature on that day. If I were to write an equation of the deer's body temperature once harvested, if its living temperature is 98.6, I would write y equals 98.6. And then again, that multiplier is 1 minus 4.5 divided by 100 to the x power, and then plus 55, because it's never going to go below 55 degrees. Now, it would be best if we actually simplify this 1 minus 4.5 divided by 100. So we would actually end up with y equals 98.6 times. The shortcut there that some people pick up on is that you could just subtract this. So we end up with 0.955 to the x power plus 55. So that's a little bit of a new idea here, that we have this horizontal asymptote never going to pass below a certain temperature. Anything follows that. You know, Mr. Warner's coffee in the morning is never going to go below the room temperature. So that coffee might start, you know, a couple hundred degrees, but as it cools, it will never go below, say, what, 62 degrees, because that's the temperature in our classroom. So, you know, anything exponential follows those same sort of rules. Linear web forms of a line given 2 points. So here we go. We have 315 and negative 4, 1, and it's linear. Keep in mind some of these forms of lines. This is prior knowledge, so it hasn't been covered too much in the book, but mx plus b is slope-intercept. Point slope form is y minus y1, mx minus x1. And then standard form actually is ax plus by equals c, and a must be positive integer. Okay, so I know you probably haven't worked too much with point slope form and standard form of a line, so we're going to go over that now. First, though, will be to write it in slope-intercept form. That usually seems to be the easiest way, keeping in mind that we have an equation for slope, y2 minus y1 over x2 minus x1. Now, if you have some other way that you remember that, that's fine. There's more than one way to do this. So 15 minus 1 are my y values, and 3 minus negative 4 are my x values. So I end up with 14 over 7, which gives me a slope of 2. Okay, so I plug that slope of 2 into my equation. And you have a couple ways to go about this from here. If my growth is 2, I could always think about this as a sequence. And I would know that my next value would be 13, and then I would have 11, and my 0 value would be 9. So that's my y-intercept. Let's go backwards, you know, each term, sort of like a sequence, until I get to my 0 value. Or I could always plug the 2 in for my m and one of these coordinates. So 15 equals m times x, which is 3, plus b. So 15 equals 6 plus b, which means b equals 9. So I have my slope-intercept form, y equals 2x plus 9. Okay, now from there, these other forms are very easy. Okay, I use the information I've already gathered. Here's my slope value. y1 and x1 are just one of my points. Pick one, it doesn't matter which. So I would do y minus 15 equals 2 times x minus 3. Kind of looks like graphing form. If you add this 15 over, a, h, and k. So similar idea. And then if I want to take my standard form here, I'm just going to take my slope-intercept form and get my x and y on the same side. All right, so I would subtract y. Okay. And then I would subtract 9. So I end up with negative 9 equals 2x minus y. So my standard form here would be 2x minus y equals negative 9. So all you need to do is just rearrange, you know, the pieces that you already have found into standard form. And finally, solving right triangles. This one here, solve the triangle for x. And don't tell me what I might give you, but this is a 90. Sorry, I did not say that ahead of time. Whoops. Okay, that's a 90, which is pretty important to be able to do this. Although you should know some of these other law of sines, law of cosines. Regardless here, this is a 30, 60, 90 to be specific. Usually what I remember here from geometry is that the side across from or opposite of the 30 is always the hypotenuse divided by 2. And then the side that is next to the 30 or adjacent to it is always the hypotenuse divided by 2 times root 3. So that would make x equal to 8 root 3. Whoops, got a sloppy 3. All right. However, you don't need to remember your shortcuts for 30, 60, 90, 45, 45, 90 if you have to do this problem. Okay. You can always just use, your sine, cosine, tangent ratios. So let's say I were to do that. Typically, what I tell people to do to start is label your sides. So this is hypotenuse, this is adjacent, and this is opposite. So I have hypotenuse and I have adjacent. Which one am I going to use? I'm going to use cosine, because cosine of an angle is equal to adjacent over hypotenuse. Therefore, cosine of 30 is going to be equal to x over 16. And let's make this a proportion, cross multiply. So 16 times the cosine of 30 is going to equal x. You're going to need a calculator for that. Some people in the first test goofed up here. Don't forget, double check that mode. Go to mode, make sure you're in degrees. Anytime you're solving triangles, you have to be in degrees. So if I do 16 times the cosine of 30, I'm going to get the decimal version of my answer here, 8 root 3, which is 13.86. So x equals 13.86. So either answer here would be acceptable. And that's it. Good luck studying for the test. And remember to go ahead and put together that study sheet and bring that with you tomorrow for the Unit 2 test. Thank you.